The price P and the quantity X sold of a small flat-screen television set obeys the demand equation below. So that's referring to this equation here as the demand equation. P equals negative 0.11x plus 220. How much should be charged for the television set if there are 60 television sets in stock? What quantity X will maximize the revenue, and what is the maximum revenue? What price should be charged in order to maximize the revenue? So I want to focus on what the variables stand for a moment. The price P, so P represents the price, and the quantity X, so this quantity is the number, how many flat screen television sets we have. So in part A, it asks how much should be charged, that's the price, for the television set if there are 60 television sets in stock. So 60 is the quantity of television sets, that's the value of X, and we're looking for the price P, how much should be charged. So in part A, we're going to use the demand equation that was given to us, P equals negative 0.11x plus 220, and we're going to let the value of X be 60, and that will tell us the price that we should charge. So negative 0.11 times 60 plus 220. I'm going to bring up my calculator. Let me clear out these keys so that you can see which buttons I'm pushing. We're going to do negative 0.11 times 60 plus 220, and we should charge $213.40 if we have 60 television sets in stock. Then moving on to part B, it says what quantity will maximize the revenue? What is the maximum revenue? So this is introducing something that hasn't been shown before, the revenue. And in order for us to answer what quantity will maximize revenue, we need to have an equation that represents revenue. There is a formula, a business formula that will give us that equation for revenue, and that formula is R for revenue equals X times P, and it's using the X and the P that we saw earlier, the price and the quantity. So we're going to use the demand equation that was given to us and substitute that in for P, the price, and that will give us a revenue equation. So we have X times negative 0.11x plus 220, and that's negative 0.11x squared plus 220x. So now we have an equation that represents revenue. So our equation represents revenue, and now we want to answer this question: what quantity X will maximize the revenue? So we have some theory to look at before we're able to answer this question. So here is the thought process that goes into this. Our revenue equation or function is a quadratic equation. I know it to be a quadratic equation because of the squared. The graph of a quadratic is a parabola. And if I know the coefficient on the squared term, what we usually call the leading coefficient, that will tell me whether my parabola is facing up or down. So this is A, which is negative 0.11, which is a negative leading coefficient, and that tells me that my parabola will be a down-facing parabola. Now this is significant because we're looking for the maximum revenue, and the maximum here will occur at this little peak, which we call the vertex. So that maximum value is the vertex. So we are going to use the fact that this equation is a quadratic, a down-facing parabola, to find the maximum value, and we do that by finding the vertex. We do have a formula for the vertex. The vertex is usually written as an ordered pair, HK, and we can find the value of the vertex with the formula negative b over 2a. So for our revenue function, we've already stated the value of a is negative 0.11, and the value of b will be this coefficient on the x term, 220. So we'll substitute those values into the formula. That's negative 220 divided by 2 times negative 0.11. I'll use my calculator to work that out. That's negative 220 divided by, and I need parentheses around the denominator, that's 2 times negative 0.11, and we get 1,000. So this is going to answer the first question on part B, what quantity will maximize the revenue? So 1,000 television sets will maximize the revenue, and we also want to know what is that revenue. So to answer that question, we want to substitute 1,000 into the revenue function. That's negative 0.11 times 1,000 squared plus 220 times 1,000. And I'll use the calculator to help me work this out. So we have negative 0.11 times 1,000 squared plus 220 times 1,000. So we get the maximum revenue to be $110,000. We have one more part to go, and we want to do this part right here. What price should be charged in order to maximize the revenue? Now we have this demand equation, which will give us the price that we should charge. So we're going to substitute x equals 1,000 into that demand equation. Negative 0.11 times 1,000 plus 220. Once again, I'll use my calculator to help me. We have negative 0.11, that's 11 hundredths, times 1,000 plus 220. And that gives $110. So we should charge $110 in order to maximize the revenue. Thank you for checking out my videos. Have a great day.